Hi everyone, we are back today with another question from the Selangor Set A 2021 trial paper. The last time around we did up to question 3 and we are just going to continue on from number 4 onwards for this part of the video. Alright, a quick message before we begin. If you found this video helpful, remember to subscribe, like, and comment down below. It will really help the channel grow. So, the question says, determine whether the following equations are a system of linear equations in 3 variables or not. Okay, so we have 3 equations down here and it is only a 1 mark question. Right, so what are linear equations? Right, what are linear equations? Let's talk about it. So linear equations, you have to have the unknown, right? The unknown has to have a power of 1. Okay, that's the first thing, power of 1. There's no square, there's no cube, it's just power of 1. Okay, and the second thing is you can't combine the variables. Okay, you know, the x, y, z, a, b, c, right? The alphabets, basically variables, right? You can't have them combined. Okay, it needs to be separated by itself. Okay, so I'm just gonna write it down here. No combine variables, right? And basically I'll just give an example, right? So you can't have it as xy, right? ab, okay, cd, right? It can't be combined. All right, so this is a no, right? You have to have it alone. So like x, y, z, a, okay, it must be alone. Now if we go back to our questions, okay, first equation, is that okay? Is that a linear equation? X minus y plus 3z plus 6, definitely, right? This is a linear equation. How about the third one? Is that a linear equation? Yes, 7y plus 3x minus z. All of it is alone for the variables. So this is a linear equation also. How about the second one, guys? What do you guys think? Right, it's not. Okay, it's not. The reason why is you can see that there is a 4xy over there, right? The xy, okay, is combined. So, yeah, we have solved our question already. So determine whether the following equations are a system of linear equations. So we kind of explained it already. The first one, yes. Second one, no. Third one, yes. And that is how you get your 1 mark. Right, so we are on question 4b right now. It says over here that solve the following system of linear equations and explain the result of the findings. We have a 4 mark question over here. So let's begin, guys. First thing first, let's label all our equations by naming them. So we're just going to name them 1, 2, 3. All right. Just by looking at them, okay, I'm gonna pick number 1 to start with. All right. So from 1, right, I'm just gonna change it up. I'm gonna make x alone. So x equals into 4 plus 2y. Let's call this equation number 4 right now. Okay, and where should equation number 4 go? Okay, it should go into number 3 and it should go into number 2, right? So let's go and substitute them. All right, substitute them. So first one, 2 bracket 4 plus 2y minus 3y plus 2z equals negative 2. Okay, we're going to solve it. So make sure, guys, you multiply because it's a bracket. So multiply both on the inside. You will get 8 plus 4y minus 3y plus 2z equals into negative 2. All right, I'm going to keep my variables on the left. I'm going to push my numbers to the right. It will be y plus 2z equals into negative 2 minus 8 will be negative 10. And that is my answer for the first one. All right, let's call this equation number 5. Okay, let's call this equation number 5. Next one. So for x, so I'm substituting x, which will be 4 plus 2y minus 7y plus 2z equals into 6. Again, multiply both on the inside. You are going to get 16 plus 8y minus 7y plus 2z equals into 6. Variables on the left, numbers on the right. Y plus 2z equals into 6 minus 16 is going to be negative 10. Okay? So, let's name this equation number 6. Okay. So normally, once you get up to this stage, what you have to do next is you need to take your 5 and 6 and you kind of either plus or minus them, right? And what will happen then is that you can cancel out one of the variables and you can find another variable, right? So say for example, you cancel out y, you can find the z variable, whatever that amount is, right? Usually. But that's not always the case. So over here, I'm trying to cancel out one variable. So I'm thinking, okay, you know what? I'm just going to do like equation number 5 minus equation number 6. Let's see what happens. So equation 5 minus equation number 6. Okay, follow me, guys. Y minus y. What's y minus y? 0, right? Simple. Next one. Positive 2z minus positive 2z. What's that going to be? Again, 0. 0 minus 0 is just 0. Okay, next one. Negative 10. Okay, so you're going to write negative 10 like this. Minus comes from the equation because we did 5 minus 6, so it comes from there. Alright, and you need to minus the negative 10 as well. Okay, and what's going to happen here is that you're going to get negative 10 plus 10, which will be 0 as well. So currently what you have is 0 equals into 0. So what does that mean when we get 0 equals into 0? That means you have an infinite possible number of solutions. So we are just going to say here that the system of linear equations have I wrote have an infinite possible number of solutions. Right? So not all the time you can, solve your variables for x, y, and z. Okay? So remember, guys, when you get 0 equals 0, okay, you have an infinite number of possibilities over here. Okay? And that is how you do question number 4b. Alright, so we are moving on to question number 5 right now. Let's go. So question number 5a says, given a geometric progression with terms a, ar, ar square, and so on, and the sum of the first term n is Sn, derive the formula for the sum of the first n terms Sn for the geometric progression when r is greater than 1. First thing first, we have to have our formulas with us, which is, I've already copied it for you guys, it's in the box down below. You can get it from the formula sheet as well. So what are we doing here with the formula? The formula on the left is when r is greater than 1. The formula on the right side is when r is lesser than 1, right? So since they want us to do the sum, we are just going to do just that, right? So sum means plus. So we're going to take all the terms and we are going to add them up. So ar squared plus ar cubed dot plus arn minus 2 plus arn minus 1. Now, because there are too many terms over here, we need to reduce the terms through subtraction, right? And we are going to do that later on, but we need something to subtract it with, right? So we're going to multiply all the terms with the letter r. So r Sn. Okay? So what happens here is we're going to get AR plus AR square plus AR cube, all right, plus dot 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 plus AR. Okay, so at the end we have a ARN minus 2, right? What happens when you multiply it with R? R has a power of 1, right? So ARN minus 2 plus 1, negative 2 plus 1 is just negative 1. It will be ARN minus 1. And for the last one, it will become AR to the power of n. N minus 1 plus 1, negative 1 plus 1 is 0. Right. Now, when we multiply by r, there is something that happens, guys, with all the terms. Okay, basically all the ones above, when we multiply with r, it shifts to the right side a little bit. Right, it shifts to the right a little bit. So this middle section here, the one with the dots, okay, is the in-between numbers, right? There's values over there, right? There is actually, right, an ARN minus 2 over there, right there. Okay, now just follow my laser pointer. Have a look, guys. So you see AR over here. See, it has shifted. So AR square, AR3, right? Cube. Okay, and look here. We got AR to the power of n minus 1, AR to the power of n minus 1. So what's the term before this? Exactly, guys. It's going to be AR to the power of n minus 2 and AR to the power of n minus 2, right? So let's go and minus and subtract the second equation with the first. We've got R, I don't want to use a red pen, I want to use a blue pen. So R as n minus Sn equals, wherever that you can cut, just cut because it's subtraction. So AR with AR, AR square with AR square, AR cube with AR cube, and AR, oops, I erased it. So cut ARN minus 1, ARN minus 1, ARN minus 2, ARN minus 2, and all that you're going to be left with is RSN minus SN equals into ARN minus A. Okay, so what can you do over here? Obviously, the first thing is you can factorize out the SN, right? So it's going to be SN bracket R minus 1 equals into ARN minus A. We are going to move the R minus 1 to the right side. You will get SN equals ARN minus A over R minus 1. And I just noticed that there is something additional that you can do because there are two A's on the left and right side. So over here, we can actually factorize out even more. So it will become ARN minus 1 over R minus 1. So we have actually derived the formula just like how they wanted us to do it. And if you guys notice, right, if you guys check this out, the formula is exactly the same like the one that we have at the top, right? So we have successfully derived our formula, and that is how you get your first 3 marks of the question. Question 5b is asking us to find the value of n for which the sum of the first two n terms is 28 times the sum of the first n terms of a geometric progression which has a common ratio of 3. Right, so just from the first sentence alone, we know that the sum of 2n equals into the sum, okay, is 28 times the sum of the first n term. So it's 28 times, so 28 multiplied by Sn for the sum of n terms of a geometric progression, right? So this is what we have. This is the information that we have. They also gave us the common ratio, which is 3. That's the R, right? So based on this, I'm going to use the first formula on the left, which is AR to the power of n minus 1 over R minus 1, because the common ratio was 3, and if it's more than 1, you use the left formula, right? So let's just go and put our values inside. So R is 3, so 3 to the power of 2n, okay, minus 1 over 3 minus 1 as well. So 3 minus 1 is just 2, equals into 28 as n. So it's going to be 28 bracket, sorry, no brackets, 28a, now the bracket, 3n minus 1 over 3 minus 1 is also still 2, right? We have fractions on the left and right side, so all we have to do is just cross multiply. Okay, so when we cross multiply, what happens? We are going to get many different types of values over here. So let's see what's the easier way to do this. Yeah, I think we just multiply, guys. I think we just multiply, right? So it's going to be 2a, right, 3 to n minus 1 equals into 28 times 2. 28 times 2 is, of course, 56. So 56 a 3n minus 1. Okay, so now we are here. I think we can sort of simplify the numbers, the 2 and 56. So we're going to divide both with 2 basically, right? So 2 divided by 2 is just a 3 to n minus 1 equals into 56 divided by 2 is just 28 a 3n minus 1. Okay, the alphabets of a as well, yeah, you can actually cut them out. I should have just cut them out just now, actually, right? So we are left with 3 to n minus 1 equals 28 3n minus 1. All right, so I believe we can multiply and expand our brackets right now, so that's what we're going to do. So 3 to n minus 1 equals into 28 times 3n. 28 times 3n. So I'm just going to write it in the bracket first. I'm not really going to do anything with it. I'm not going to multiply it. Just going to leave it side by side to each other, right? 28 3n and minus with 28, just like this. Okay, now that we have this right now, okay, now that we have this, the 3 2n at the left side, right, this one here, right here, okay, we can actually break this apart. Okay, like I kind of want to split up the n and the 2 from each other. So this will become 3n, power of 2 goes right outside the bracket, minus 1 equals into 28 3n minus 28. Now the reason why I did that, if you notice, now I've got 3 to the power of n on the left and also 3 to the power of n on the right. Okay, so let's just go back to the question and see if I missed out anything or not. No, not really, I didn't. Okay, everything's okay. Right, so now that we've got 3n and 3n on the left and right side, the easiest way to solve this, guys, is that we have to say 3n is something. So we're going to let it be something. Okay, so I'm just going to write let 3n be y. All right, so then it will be y. The whole equation will be y squared minus 1 equals into 28y minus 28. Now, it looks like we have a quadratic equation on our hands, right? So y squared minus 28y, push everything to the left, minus 1 plus 28 equals 0. You will get y squared minus 28y plus 27 equals 0. Ooh, this is a long equation, guys. All right, so right now, all we have to do is pretty much just use our calculator to expand our work, right? So your A is 1, your B is negative 28, and your C is positive 27. Use your calculator to expand it, or to solve the problem, basically, to solve the equation, right? So we will get Y as 27 and Y equals 1. If you want to write it in the brackets, you can actually, right? I'll just leave a space. So Y minus 27, Y minus 1 equals into 0. Okay. Now, over here, since we've already solved our equation, we are going to substitute back again what we had just now. Okay. So this will be 3 to the power of n equals 27. Okay, let's solve this first, and then we'll tackle the other one later. So 27, can I change it into like something else? Of course I can. It will be 3 to the power of 3. And since the base is the same, right, the powers at the top can equal into each other. It will become n equals into 3. Now, I'm going to do the same thing for the right side as well. It will be 3 to the power of n equals into 1. Can I change 1 into something else, right? Yeah, I can. It will be 3 to the power of 0. Now, is our base the same? Yes, it is. Okay, it will become n equals into 0. And we actually have solved our equation already, right? So n can't be 0. So this will just say down here that this is not accepted. All right, and n equals 3. That is basically our final answer. All right. So yeah, it was pretty long, and you guys got your 4 marks. Okay, so here's the entire question, guys. If you guys are ready, let's move on to the last part of this video, which is question number 6. Alright, question number 6 states that we have a diagram that shows part of a graph of y against x for the equation y equals p to the power of x q such that p and q are constants. They want us to sketch the straight line graph of log 3y against x, hence mark and state the coordinates of the corresponding point A and B. Right. Log 3y against x. Okay, so x and x is pretty much the same, right? So all that we need to do is just pretty much have the log 3y in our straight line equation, right? So we are going to change. We're going to start by writing down our equation first. Y equals into px q. Since they want us to have log 3, right? So we're going to log 3 on both sides. So log 3y equals into log 3y, and inside here we have px and q. So px and q, I'm just going to put them in a bracket. Okay, now since they are I need to take out the y because I mistakenly put that in, right? I wanted to just log 3 on both sides, right? Okay, so back to our question, right? P to the power of x times q, right? So what are the logarithm rules? For times, you can split it up, it will become plus. So log 3y equals into log 3px plus log 3q. Okay, now the power of x, you can of course bring it down, so it will become x log 3p plus log 3q log 3y on the left side. Now if you were to compare the equation, right, to y equals into mx, and usually it's y equals into mx plus c, right guys? But since I've already written it like x in front, I'm just gonna write xm. Okay, so xm plus c, right? So you can see that my y is actually log 3y, my x is x, my m is actually log 3p, and my c is log 3q. Okay, so we're gonna have a little small table on the left side. So x is still x, so x goes here. 1 and 3. Okay, so where did I get the 1 and 3? I've just gotten it from the graph, right? So 1 and 3 over here. Now, the bottom of the table will actually be log 3y, right? Now, your y values, you kind of have to substitute that into the log 3y. So that's what I'm going to do. I'm going to start with log 3. The first y value was 9. So I'm just going to put 9 here. Now, is it possible for us to change this into something else? Yes. Log 3. 9 is actually 3 squared. I can bring the square down. It will become 2 log 3. And you guys know what to do, right? Log 3. That's just going to cancel out. And all that you'll be left with is just a 2. So I'm just going to put a 2 right in my table. Okay? And I'm going to be doing the same thing, right, with the log 327. So log 327, log 327, we can change it to 3 to the power of 3. And bring the 3 down. Okay, you'll be left with 3 only, because log 3, we're going to cut it out. So I'm just going to put the 3 in my table. Okay, so they want us to sketch a graph. So just draw your axis first. All right, you've got x over here, and you've got log 3y over here. Okay, so we actually converted from a non-linear equation to a linear equation already, so it will be a straight line. So maybe 1 and 2 will be somewhere around here. All right, this is your 1, this is your 2. All right, and 3, we can just put it somewhere around here. Okay, so this will be 3, and this will be 3 as well, right? And just connect the lines up. Okay, just write your coordinates down. This is 1 and 2, and 3 and 3 over here. And you are done. You have actually found your coordinates already, and you have sketched your straight line graph, and you got 2 marks for it. All right, let's move on to the second question. Right, the last and final question, 6b, they want us to calculate the value of P and Q, right? So we are just going to write down our previous formula or previous equation given from the question, which was y equals into pxq, right? And we are going to take our two original values, which was 3 and 27 and 1 and 9. Okay, so we've got b as 1 and 9, so I'm just going to write it over here. So b is 1 and 9, and a was 3 and 27. So a was 3 and 27. Okay, so we're going to take these two coordinate values, right, and we are just going to substitute them into our current equation. Okay, so starting with the first one, for a, which would be x would be 3, and the y would be 27. So 27 equals into p to the power 3 and cube. And we are going to do the same thing for the b coordinate as well, which would be 9 equals into p to the power of 1. So I'm just going to write that as p, okay, cube. Right, so just use simultaneous equations, guys, to get the value of either p or q, right? For in this case, I'm just going to call this is equation number 1, and this is equation number 2, okay? And I'm pretty much going to divide them up. I'm going to divide equation number 1 with equation number 2. So I'm just going to write here, I'm going to take 1, I'm going to divide it with 2. So it will become 27 divided by 9 will become 3, okay, equals p cubed divided by p, okay, you will get p squared, and q divided by q, it's pretty much gone. You cancel that out. So you're going to get p squared equals 3, and you're just going to be p equals into square root of 3, right? Because you want to get rid of the square. So if you want to get rid of the square, you must square root. Right. Now that we've got p alone already, and we found our value of p, right? What do we do with it? Well, we're just going to substitute it into our second equation. So it will be 9 equals into square root of 3 q, right? We want q to be alone right now. So we must push the 3 or the square root 3 to the other side. So it will become q equals 9 over square root 3. Now, let's just make this look a bit nicer. We're just going to rationalize the denominator a bit. So multiply by set 3, multiply by set 3 as well. Alright, you are going to get 9 set 3, top times with top, bottom times with bottom. And set 3 times set 3 is just 3. You can simplify the value over here. So 1 and 3, you will be left with 3 set 3. And that is how you do it. Right. So that's the end of the question 6, and that is the end of our video right now for part 2. Stay tuned for part 3, guys, where we'll be discussing the following 3 sets of questions. Right? Guys, before I go, remember, if you enjoyed this video, right, please leave a like down below. You guys can comment anything you want. If you want me to try out a certain question, send it to me, right? Send it to me, send it to my Instagram, okay? All right, bye for now, everyone. See you guys on the next video.